Hello everyone and a very good afternoon to you all. In today's class, I'm going to start three-dimensional geometry. This is considered as one of the toughest area, comparatively similar to integration, the weightage part of it. So this time I'm going to cover many videos based on three-dimensional geometry. So this is the introduction class on three-dimensional geometry. So let me first tell you what all we are going to learn in this chapter in 12th grade. So this is the content of the chapter. The first we learn the direction cosines and direction ratio of the line segment joining 2 points. We already know how to find DC and DR in vector algebra. So we use that over here. So vector is the tool to solve three-dimensional problems. So we use vector algebra to solve three-dimensional geometry problems. So vector is like a tool to solve it. So first we find DC and DR and an exercise is being devoted for this. The first exercise is primarily this. The second exercise is finding the equation of a line. We all know, you have learned in your earlier classes how to find equation of a straight line if it's in a two-dimensional space. Y equals to mx plus c or y minus y1 equals m times x minus x1. Isn't it? So to find the equation of straight line in a two-dimensional space, we need slope and a point. Like that, even here we need two important information to find the equation of the line. So when I take up this topic, you will come to know about that. The third exercise is the equation of plane. Third one is equation of plane. So just like equation of line, equation of plane also have some conditions, and based on that we find equation of plane. Then we have combination of lines and plane models. So a case situation where lines and planes are given and we need to find something out of that. So this would be major part of your miscellaneous exercise. And then angle between two lines. This will come with equation of line. Angle between two planes. This will come with equation of plane. And then angle between a line and a plane. This will also come after you finish equation of plane. So equation of line, then angle between two lines, equation of plane, then angle between two planes, and then angle between a line and a plane. And then you will find distance between two skew lines and coplanar lines. So what is skew, what is coplanar? You will come to know when we discuss that in detail. And last, distance of a point from a plane. Distance of a point from a plane. So this is the content of this chapter. Okay, so I try my best to make a video on each of these topics in covering NCERT model questions. Once you learn the concept clearly, I'm sure you can apply to any area or any type of questions that come up, that you get it. So let's get started with the chapter. Today's class will be concentrating on DC and DR of vector algebra. Thank you. So here is exercise 11.1. Let's start with the first question. If a line makes an angle 90 degree, 135 degree, 45 degree with x, y, z axis respectively, find the direction cosine of the line. What is direction cosine? The angle, the cos angle the line makes with the x-axis, y-axis and the z-axis. A required line is making angle alpha, the cos angle alpha, cos alpha with x-axis, cos beta with y-axis and cos gamma with z-axis. And it is represented by L, M and N generally. Okay, so from vector algebra you must have known this, that L square plus M square plus N square equals to 1, or cos square alpha plus cos square beta plus cos square gamma equals to 1. Now here they want us to find only the DCs, which means we just have to find cos alpha, cos beta, cos gamma value. So let's assume alpha is 90. So first one is cos alpha. What is cos alpha? Cos 90. Cos 90 is 0. Then the next one is cos beta, and beta is 135 degree. So 135 degree, we split it as 180 minus 45. 180 minus 45 falls in the second quadrant where cos is negative. 180 means supplementary, no change. So you get minus cos 45. And hence the answer is minus 1 by root 2. And then the third one, cos gamma, which is cos 45 degree. And cos 45 is 1 by root 2. Hence, the DC is 0, minus 1 by root 2, 1 by root 2. So this is for the first one. Now let's see the second one. Find the direction cosine of the line that makes equal angle with the coordinate axis. So here the angles are all same. That means alpha equals beta equals gamma, right? So that means cos square alpha plus cos square beta plus cos square gamma is 1. But since alpha, beta, gamma are same, you get cos square alpha, again cos square alpha plus cos square alpha equals to 1. So we get 3 cos square alpha equals to 1. Implies cos alpha equals 1 by root 3 plus or minus. So therefore the DC of this is plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. This is for the second one. Okay, now let's see the third question. Third one, if a line has a direction ratio minus 18 plus 12 and minus 4, what is its direction cosines? Come on, what is direction ratios? Direction ratios are nothing but the components of I, J and K. Correct? So third question. If you wanted to form a vector, you can do that. So let's take it as A vector being minus 18 I cap plus 12 J cap minus 4 K cap. Now let's find the magnitude of A vector, which is root over minus 18 square plus 12 square plus minus 4 square. So what do you get as a result of this? You get it as 22. Square the numbers, take the root, you will find it is 22. Hence, the DC is the dr by the magnitudes. So DC would be minus 18 by 22, 12 by 22, minus 4 by 22. Which you can further simplify and write it as minus 9 by 11 minus plus 6 by 11 and then minus 2 by 11. So this is the third sum. Now, fourth question. Fourth question, we need to show that the following points are collinear. Now, collinear means all points lie in a straight line, right? So collinear means two vectors are said to be collinear irrespective of their direction and magnitude. So there are multiple ways to prove it's collinear, but if you consider my method, I think it would be easier for you. Consider one point as the reference point. Out of the three, consider one point as the point of reference. So let me name the points. I'm going to give a name to these points. Let it be A, let it be B, and let it be C. So I'm going to take A as my reference point. So that means I'm going to aim of getting AB vector and then AC vector. AB vector and AC vector. And if you prove AB vector or AC vector, AB vector is lambda times of AC vector, then it is collinear. So take one out of the 3 points as a reference point. View the other 2 points from this point. and then see whether one vector is lambda times of the other. And in that case, if you prove it's lambda times of the other, then it is collinear. And I hope you all know how to find AB vector. AB vector is OB vector minus OA vector. Position vector, likewise AC vector is OC vector minus OA vector. So once you find these two, you will definitely find that AB is lambda times of AC. Hence it is collinear. So this is how we do the fourth question. Now the fifth one. Find the direction cosines of the sides of the triangle whose vertices are. Now, whenever you get a question like this, read them carefully. Sometimes they will give you the sides, sometimes they will give you the vertices, sometimes they will give you the side vector. The vectors, the side of the vector would be given. So it's very important to read the question slowly and carefully. So third question. Fifth question, not the third one. Fifth one. Okay, so fifth question with the diagram in front of you. A triangle is being drawn and vertices are named. We need to find the DC of the sides. So let's find the side vector. Let's find AB vector. Now AB vector is OB minus OA. So minus 1 minus 3, which is minus 4. So we get minus 4i, and then 1 minus 5 minus 4j, 2 minus of minus 4, so plus 6k cap. So this is AB vector. Now how do we find the DC of AB vector? We need to find the magnitude of AB vector for that. So which is root over minus 4 square including minus, and then minus 4 square again plus 6 square. So this is how we find the magnitude, and the result of this would be 17. 2 root 17. Yeah, the result of this would be 2 root 17. So DC is what? dr by the ratio minus 4 by 2 root 17 minus 4 by 2 root 17 and 6 by 2 root 17. So this will further reduces to minus 2 by root 17, minus 2 by root 17 and 3 by root 17. So like this, you need to do it for all the other sides also. I did for AB, you have to do it for AC and BC also. So after you find BC, find the magnitude of BC, then the components of IJK, which is dr divided by the magnitude, will give you the DC. So I did for AB, I'm sure you will be able to do it for AC and BC also. So with this, we are done with the first exercise of three-dimensional geometry, where we understand how to find DCs and DRs. So in my next class, I'm going to teach you the equations of straight line. Hope you understand what I taught. If there is any doubt, put it in the comment section and try to share this video those who are in need. Thank you.